Okay, good morning, everybody. I have an audience of one today in the lecture. All right, so today we're talking about we're still in part 3 of the course, right? We're at the end of part 3, that's right. So we're talking about inheritance today. Now, we've already talked about we've talked about relationships between classes. So we've talked about dependency, association, aggregation, composition. Right, so the strength of the relationship between classes increases from dependency towards composition. There's one more important relationship between classes that's actually stronger than composition, and that's called inheritance. So an inheritance is a relationship between two classes where one class is derived from another. And there's a quote here from the Java tutorials about object-oriented programming. And so it reads, "The idea of inheritance is simple but powerful. When you want to create a new class and there's already a class that includes some code that you want, you can derive your new class from the existing class. In doing this, you can reuse the fields and methods of the existing class without having to write and debug them yourself." And so inheritance, one view of inheritance is that it's a form of code reuse. Right? You've got an existing class that already does what you want it to do, so you can inherit from that class or derive another class from that class, and you get all of the public or all of the non-private features of that class for free. And so inheritance and interfaces are the two Java mechanisms that support creating what are called hierarchy of classes. So this is the fourth part of our object model. And so here's a picture. This is not a UML diagram. This is just a sketch of what inheritance sort of looks like in Java. I guess the important thing that this slide is trying to convey is that in Java there is a class that sits at the top of the inheritance hierarchy, right? And that class is java.lang.object. And so that the class object has a special place in the Java language. Now the class is in the second row of this picture. Right? So these are all connected to object via a solid line in this case. So the classes in the second row, these are all the direct descendants or the direct subclasses of the class object. And so everything in the second row, those classes are descended from object. In this row here, right, so this class is connected to the one above it via a line. Right? And so this class, this class right here is descended from the class immediately above it, right? But in Java, it's also descended from the class object as well, and so on and so on and so forth. So, for example, this class down here, its immediate so this class here is descended from this class. This class is descended from this class. This class is descended from this class, and this class is descended from object. So there's some jargon that you need to get used to or to understand when you're talking about inheritance in object-oriented programming languages. So what we call a subclass, which is also called a derived class. Java sometimes uses the term extended class, and you can also use the term child class. These are all the same name for a class that's derived from another class. So in the picture, in the UML diagram or UML class diagram, when you draw an inheritance relationship, you draw the subclass, right? You draw the superclass, and you connect the subclass to the superclass with a solid line and an open triangular arrow. Right? The shape of the arrowhead is actually significant in UML. Right? So it's actually this open triangle that you use. The superclass, sometimes called base class or parent class, is the class that the child is derived from, or is the class that the subclass is derived from. Right? So an example in Java would be object. Right? Java.lang.object is the superclass to string, right? And string is the subclass of object. Right? I guess to be more specific, string is the immediate subclass of object, and Y is the immediate subclass of X in this case. And the reason I use the term word immediate is because you can have a chain of subclasses. right? So a class can be derived from a class, that's derived from a class, that's derived from a class, and so on. In Java, you always end up back at the class java.lang.object. Right, so here A is the subclass of Z, which is the subclass of X, which is the subclass of object. So we say that any class below object is descended from all of the class, the class A is descended from all of the classes going back to object. Right, so it's descended from Z, X, and object. You can also say that the classes object, X, and Z are the ancestor classes of A. Right. Okay, so why do you want to use inheritance? So a subclass inherits all of the non-private members, fields and methods, but not constructors, from its superclass. Right, so any member that's public, your subclasses inherit those features from the superclass. You're going to see shortly that there's another access modifier called protected. And your subclass also inherits all of those protected methods and fields from its superclass. Now notice that a subclass never inherits the constructors from the superclass. Right? So when a subclass has a constructor, it needs to when a subclass needs a constructor, it needs to define its own. Right. Now, why are we using inheritance? Because if you have an existing class that provides some functionality that you need, you can derive a new class from the existing class. Right? The new class gets direct access. So direct access means by name, right? To the public and protected fields and methods without having to declare or re-implement them. Right? So that's important too, right? So if you inherit from a class and it's got some field that you want to reuse, that you can access, then you don't redeclare it. Right? The field lives in the superclass. The subclass can still use it. Similarly with the methods, right? If your superclass has methods that you want to use, don't redefine them. Right? There's no need to redefine them, just call the methods directly. Now, of course, the new class can, if it needs to, add new fields and methods to itself. Right? And the new class can change the definition of any public or protected method that it inherits from its superclass. Right, now we've already seen examples of that where we've overridden equals toString and hash code. Right, so we've actually been using inheritance all along, even though I never explicitly told you that we were doing so. So inheritance is a relationship between two classes. The relationship that it models is the is-a relationship. Is the is-a relationship. Now, in object-oriented programming languages, is-a usually means is substitutable for. Right? So it's short for is substitutable for. A subclass object should always be substitutable for one of its ancestor objects. Right? So for example, if you have a method that takes in a big O object, right, you should be able to pass a string to that method, and the method should work correctly. Right? And why is that? Because strings are substitutable for big O objects. In Java, the class java.lang object is unique, so it has a special place in Java. It's the only class that has no superclass. Right? So every other class in the Java language has at least one ancestor class, right? And so that class is going to be object. So it's the class from which all other classes are descended from. Now, we've been making classes since, I don't know, roughly week 3 of the course. Maybe, I guess even the first course, even the first lecture, because we had to make a class to have a main method. Right? So when we've made a class, we've never said anything about descending from object. Right? So if you create a new class and you don't explicitly state what the superclass is, then the superclass for your new class is object. In Java, a superclass is allowed to have an arbitrary number of subclasses. Right? So 0 up to no upper bound. Right? So here X has 3 subclasses, right? It could have 4 or 5, 6, whatever, right? But in Java, a subclass can have only 1 superclass, right? I guess more precisely, a subclass has exactly 1 superclass, right? So Y has 1 superclass, and that's X, right? Or 1 immediate superclass, right? Z has 1 immediate superclass, that's X. W has 1 immediate superclass, that's X, right? Oh, I should also mention that this relationship called inheritance is one way, okay? So the child, so Y, inherits from X, or is descended from X, or is the subclass of X, right? So Y has a relationship with X, right? X has no explicit relationship with Y, right? So this relationship is strictly one way, right? So Y knows about the existence of its superclass, right? The superclass has no idea that its subclasses exist, right? So the class java.lang object, it doesn't know that string's a bad example. It doesn't know that ArrayList exists, for example, right? It doesn't know that our point2 class exists. It doesn't know that our counter class exists, right? So inheritance is a one-way relationship. The fact that a subclass has exactly 1 superclass in Java is called single inheritance. So there are other object-oriented programming languages that support multiple inheritance, where a subclass can have more than 1 superclass, right? And so here's a picture. This is not Java. This is some other programming language, right? Some other object-oriented programming language that supports what's called multiple inheritance. So single inheritance, though the way Java does things, prevents a problem called the deadly diamond of death that occurs in programming languages that allow for multiple inheritance, right? It's got a funny name, but if you actually Google deadly diamond of death, you will find the Wikipedia page that describes this problem, right? So that's actually its real name. So in the deadly diamond of death, you've got this problem where you have a class Z that inherits from more than 1 superclass, right? So it inherits from Y and W, right? So it has 2 direct superclasses, right? Now Y only has 1 superclass X, W only has 1 superclass X, right? So the problem that happens is, suppose X defines a method, right? We'll call it F, right? We've got 2 subclasses, Y and W, right? Now Y and W, they're allowed to change how the method F behaves, right? So Y overrides F to do whatever Y needs to do, right? W overrides F to do whatever W needs to do, right? And now Z inherits from both Y and W. So the problem that occurs is, which version of F does Z end up inheriting, right? Does it inherit Y's version of F? Does it inherit W's version of F, or does it inherit X's version of F? Right? And so that's the problem that occurs when you have multiple inheritance, right? You need some mechanism or mechanisms to resolve that issue, right? Java's mechanism is to not allow multiple inheritance, right? So only single inheritance occurs in Java. Now, you might think that this could be useful, right? It might be useful to inherit from 2 classes at the same time, and it is. Java doesn't allow it. But what Java does allow is that a class can implement as many interfaces as it wants, right? And so that's Java's workaround for this multiple inheritance problem, right? If you need something that looks like multiple inheritance, implement multiple interfaces instead, right? And that's perfectly fine in Java. So I guess the question is why can you implement multiple interfaces in Java, right? And so the answer is, if you have 2 interfaces with the same method name, right, then you can always resolve which method is called by using the fully qualified interface name. Right? So actually, is that what happens if you inherit? Actually, that's true. What happens if you? Actually, I think that might be incorrect. I have to look up what happens in that case. So if you try to implement 2 interfaces that have the same method with the same signature, I actually don't know what happens in that case. I'll look that up and amend the slides, I guess, or tell you what happens in the next lecture. Yeah, that's never actually happened to me before. So let me look that up and make sure and give you the correct information. Okay, so no multiple inheritance in Java, only single inheritance. All right, so this, the fact that inheritance is supposed to model is-a, or is substitutable for, right, means that you are supposed to be able to use a derived class object, right, anywhere where you need an ancestor class object, right. So I have some method that takes in a reference to an object, right. So here's the class sum class. It's got a method called sum method, right. The parameter of sum method is a big O object. Right, and in here, the method does something with obj. Right, maybe it calls toString, maybe it calls equals, I don't know, it does something, right? So anywhere else, right, you can import some class and then call some method, right? Do I have to pass in a big O object? No, I can pass in a string, for example. Right, so I can make a string s, and I can call some method with the string s, right? And that works just fine, right? The compiler is perfectly happy with it. The code runs the way the code runs, period, right? You can make a hash set, right? Pass in the hash set to the sum method, right? And that's fine, because hash set is an object. There's an error on this slide. That's P. Oop. Right? I can make a point, right? Pass it into some method. Everything compiles, program runs, right? So the subclasses, right, of object, string, hash set, point to, right? Objects of those types are substitutable for objects of type big O object, right? So anywhere I need an object, I can pass in whatever I want, right? And that's why equals, the method equals, works or is defined the way that it is defined, right? So equals is defined to take in a big O object. What does that mean? You can pass in any reference to the equals method, and it will do something. Okay, now what you have to remember when you're doing, when you're working with inheritance is that is substitutable for has nothing to do with the real world, right? So this is strictly a programming concept, right? This is strictly a concept that's in object-oriented programming, right? So is substitutable for has everything to do with how you've chosen to model your inheritance hierarchy, right? So in other words, it strictly depends on how you've decided to model the problem that you're trying to solve. So the classic example is a circle an ellipse, right? So in other words, if you're implementing a hierarchy of classes for shapes, right, you might have already implemented your class called ellipse, right? Now remember what an ellipse is, right? So an ellipse is, it looks like an oval, right, or a symmetric oval. Mathematically, an ellipse is just a special kind of circle, right? Or a circle is a specific kind of ellipse, I guess is the better way to say it, right? And so you might say, you might choose to try to implement your classes by having circle extend or be the subclass of ellipse, right? And when you do this sort of thing, you're always asking yourself, is this the correct thing to do, right? Keeping in mind that this is programming and not math. Right? Okay, so mathematically a circle is a kind of ellipse. So that immediately leads you to thinking this is reasonable. Right? But what you have to keep in mind is that if the ellipse class can do something that the circle class cannot, right? So the circle can't do everything that an ellipse can do, right? And what does that mean? It means that you cannot substitute a circle object when you need an ellipse object, or when you're asked for an ellipse object, right? Because the circle object can't do everything that the ellipse object can do. And that's a problem, right? So that's a problem in terms of inheritance, right? Right? So remember what is-a means. Is-a means that you can substitute a derived class instance for one of its ancestor instances, right? So in other words, if I have a method that takes in an ellipse, I'm supposed to be able to pass that method a circle, and the method is supposed to do what the contract of the method says it does. Right? Now, if a circle can't do something that an ellipse can do, then I can't safely substitute a circle for an ellipse. Right? Notice the word safely here. Right? As far as the language is concerned, you can always call a method that takes in an ellipse, and you can always call a method that takes in an ellipse and passing in a circle. Right? So the language doesn't care. Right? What matters, though, is how that method behaves. So what matters is how that method behaves when you're writing code using circle and ellipse, right? Because circles are supposed to be substitutable for ellipses if we choose to use inheritance. So imagine that you have this method in the superclass, right? So remember, ellipse is the superclass, right? I've got this method in the superclass called setSize, right? So an ellipse is an oval type shape, so it has a width and height that are independent, right? And so that's the important part in this question, in this problem. Right? In ellipses, the width and height of the ellipse are independent. Right? So setSize does the contract for setSize says that setSize will change the width and height of the ellipse to the specified width and height. Right? So in other words, if you pass in a width, positive, so a positive width and height. Right? So if you pass in some positive value of width, you pass in some positive value of height. You satisfy the preconditions of the method, right? The postcondition of the method says that the width and height of the shape changes, right? And so that's what the method is supposed to do. Now, someone who's writing code using your ellipse class, right, is allowed to depend on this contract, right? So they read the contract of the method and they say, oh, hey, this changes the size of the shape, right? Furthermore, it promises to change the size of the shape to that and that. Right? And so whoever's writing code using your class is allowed to, or should, assume that this is the case. Right? They read the contract, they write their code according to this contract. Right? Now, someone can cook up some code that actually depends on the width and height being set to specific values. Right? Maybe they make some really neat picture where everything has to have some precise size. Right? And so they're relying on this contract to actually change the width and height. Right. Now, what's the problem with what's the problem that occurs in this situation? Right. So the contract says that the width and height of the shape will be changed. Right. Now, if you do this for a circle, right, that doesn't produce a circle. Right. Circle, the width and height of the circle are equal to one another. Right. So circle can't actually implement this method correctly. Right? So circle can't implement setSize and change both the width and height of the circle, right? Because then it's no longer a circle. Right? In other words, it can't do what this contract says it's supposed to do. Right? Oops, sorry. Okay, so that's a problem. So right away, you've got a problem. Right? If you try to force, or if you try to implement circle as a subclass of ellipse, right, then anybody who wrote code using ellipse's contract for setSize, right, their code no longer works or doesn't behave the way they expect it to when you pass it a circle object. But circles are supposed to be substitutable for ellipses, so now you've got a problem. Right? Now, what if there is no setSize method? Right? So if there's no setSize method, then maybe this problem goes away. Right? The only way that you can tell if the problem goes away is to check. Right? So for every method that's in the ellipse class, can circle provide a method that also does the same thing? Right? So can every circle method obey the corresponding contract that's written in ellipse? Right? Again, because anybody else who's using your code is allowed to look at the ellipse contract, right? The API or the documentation for the ellipse class, right? They can look at the documentation for all the methods, and all of those method contracts should also apply to circles. If that's the case, then yeah, go ahead, have circle extend ellipse or be a subclass of ellipse. Right? If not, then you should think very hard whether or not you're going to have circle extend ellipse. Right? And in fact, you probably shouldn't do it. Right. Now again, remember that this is all, so there's nothing in the language that can check if a subclass obeys or satisfies its parent class contracts. Right? There's nothing in the language that does this. So it's purely the responsibility of the implementer to make sure that every subclass that's created obeys every contract, every method contract that's in the superclass. Okay, so here's a naive example of inheritance, right? So when people first hear about inheritance, or when programmers first hear about inheritance, the tendency is to start to use inheritance everywhere. which is not the modern recommendation for inheritance, right? So we've implemented stacks, right, in 3 different ways now. So here's a 4th way that you can implement a stack, right? So one of the ways that we implemented a stack is to internally use a list, right? So we actually used composition to implement a stack, right? Every stack has and owns a list, right? So every list-based stack has and owns an internal list object, right? So that's one way that we've implemented stack using composition. Now, if you actually look at what we talked about, right, it really does look like it really does seem to be the case that a stack looks a lot like a list, right? You push an element onto the stack, that's adding an element to the end of the list, right? Popping an element from the stack looks a lot like removing an element from the end of the list, right? So one way that you can implement a stack is to have your stack class inherit from an array list or linked list, right? Now, why might we want to do this? Because we get to inherit all of the public features, or all of the protected and public features of the list class, or of the array list class, right? So what does that mean? I get add and remove for free, right? Furthermore, I get all of the storage of the elements for free, right? So if I say stack is a list, right, then I get all of the, I get the mechanism, whatever mechanism that the array list uses to store its elements, right? And I don't have to redefine it myself, right? So can we do this? The answer is yes, right? So let's look at an example of implementing a stack using inheritance, right? So when you create a class that is a subclass of something else, right, then the word that you use is extends. Right? So the keyword extends is the Java keyword that indicates you are explicitly using inheritance. Right? So bad stack, which it's called bad stack for a reason, right? This is not a good way to do this. Right? So bad stack extends an array list of integer. Right? So it looks like I'm going to make a stack of integer values. Right? Again, Java only supports single inheritance, so you can only ever extend one class. What does push look like? Well, push, I have to add an element to the end of a list, right? But bad stack is a list, right? So what does that mean? It has an add method, right? It's got an add method that it inherited from array list. So I can simply call the add method and add the element to the end of the bad stack, right? So this dot add the value. How do I pop an element from the list? Well, I want to remove the element from the end of the list, right? Bad stack is a list, right? That's what we said. So I can just call the remove method and remove the element at the end of the list, right? Remove even throws an exception for me if this index is incorrect, right? So if the stack is empty, remove throws the exception for me. I don't even have to write my own exception here if I don't want to, right? My own test for an exception here if I don't want to. Right, and that's it. Now notice there's no field, right? There's no field up here, right? I don't need a field because the array list class does everything for me, right? It stores the elements for me. It tells me what the size is, right? I don't need any field whatsoever. And there's not even a constructor, right? No constructor either, right? Which also looks weird. But this is it. This is a complete and functioning stack class. So you can make a new stack, right, by calling the no argument constructor. Now, why does this work? Because, right? Because if you don't define if you define no constructors for a class, Java gives you the no argument constructor for free. Right? Now, exactly what the no argument constructor does in this case, I'll tell you probably next class. Right? All that we care about right now, though, is that we have a no argument constructor and it works, right? So I can make an empty bad stack. I can push 0, 1, and 2 onto the stack, right? So 2's on the top, 1's second, 0's on the bottom. I can print the stack. This is cool. Look, so I can print the stack T even though there's no toString method, right? I haven't defined toString for stack, but I can still print it and I still get something sensible, right? What do I get? I get the 2-string version of array list, right? I get it for free because bad stack extends array list. So that looks pretty cool, right? I can pop the stack, right? And it even pops the right values, right? So when I pop the stack, I get the 2, which is good, right? I pop it again, I get the 1, and I pop it again, I get the 0. Everything seems to work, right? If you ask for the size of the list, it would also work. If you asked, is the list empty, it would work, right? So I get all this stuff for free, which is the appeal, or which is the initial appeal of using inheritance. Now, why is this a bad thing, right? So when using inheritance from array list to implement bad stack, you're saying that a stack is a list, but it's not, right? Stack is not a list, it's a stack, right? If you use inheritance, you're saying stack is a list. So anything that a list can do, a stack can now also do, right? So for example, you can get an element from the middle of the stack, right? Which you're not supposed to be able to do in a stack, right? You're only supposed to be able to look at the top element. You can change an element anywhere in the stack that you want. Again, you're not supposed to be able to do that, right? You're only supposed to be able to do something at the top of the stack. You can remove any element in the stack. You can iterate over elements in the stack. Now that last one might actually be useful, right? So that's actually not a disadvantage in this case, right? You might actually want to be able to iterate over the elements of the stack. Similarly, you also get a bunch of other stuff that could be useful. You get equals for free, right? So equals will check if 2 stacks have the same sequence of elements. You get 2-string, which we've seen is nice, right? You get hash code, which is also nice, right? I don't have to re-implement hash code. Unfortunately, you also get all the other methods, which you don't necessarily want if you're trying to implement a data structure that is strictly a stack. Yeah, question?
Does that stack inherit the constructors?
No, you never, inheritance never inherits constructors. Constructors are never inherited. You will see why probably next class. Okay, so using inheritance to implement a stack is an example of an incorrect usage of inheritance. In this particular case, it's not the end of the world, right? Your stack class still behaves like a stack. It's just that you can do other stuff with it that you might not be expecting to be able to do. Right? So you should only use inheritance when this is a or is substitutable for relationship exists, right? Stacks are not technically lists. Therefore, you should not use inheritance to implement the stack, right? Now, if this seems a little confusing to you, you should not feel bad because even people with many, many, many years of programming experience have screwed this up, right? So the I guess the early versions of the Java language actually implemented a stack class, right? And it's still there in the standard library. So if you look at javautil.stack, the documentation for that class, you'll see that there's a stack class, right? What does the stack class do? It inherits from a class called vector. What's vector? Vector was Java's original list implementation. So the designers of the language got this wrong, right? They created a stack that inherited from a list-like structure, right? And as a result, their stack class is essentially a list, right? You can do anything you want with that stack that you can do with a list. Right? So the tendency, especially, I guess, in the mid-90s or even earlier, right? So in the early days of the Java language, when people did not have so much experience using object-oriented languages, was to use inheritance in places that it should not have been used, right? And this is one of the consequences of that mistake. Right? Now the problem, now you might wonder why they never got rid of this class. And so the answer is because it was probably relatively widely used before they realized that there was an issue. Right? And now you can't get rid of it because so many other people have used it already. I guess the other reason they haven't gotten rid of it is because the fact that they used inheritance here is not that big a deal, really. Right? Yes, your stack behaves like a list, but in most cases that's not really a problem. Okay, so what is the correct way then to implement a stack? Well, the correct way if you want to use a list is to use composition, which we already did. Right? So we implemented a stack using composition. Remember what composition means? Stack has and owns its own list. Right? And that's exactly what you want to do in this case. the implementation using composition is not significantly more complicated than using inheritance. Yes, we had to add a field, right? But other than that, it's almost the same. So the modern recommendation when thinking about using inheritance is to avoid it if possible, and instead to use composition, right? So in other words, favor composition over inheritance. Right? Now that doesn't mean never use inheritance, right? It just means don't overuse inheritance. Right? One of the reasons for using, I guess one of the significant reasons for using inheritance is that it gives you a mechanism for code reuse. Right? And code reuse is always a good thing, right? If you don't have to write the same code twice, don't. Right? Because if you do, you end up having to test it twice, right? You have to maintain it 2 times now and all sorts of other problems. Right? So code reuse is good. Inheritance happens to be a mechanism that lets you perform code reuse. Right? So one example of using inheritance for code reuse is the counter class. Right? So remember this counter class that we've been talking about? It's like the world's simplest class. Right? It just counts from 0 to some number. Right? It turns out you can also adapt this class and turn it and use it as part of an inheritance hierarchy. Right? So in our current implementation, when the counter hits integer max value, if you advance the counter again, it wraps around to 0. Right? But that might not be the way you want the counter to behave. Right? So someone else who's using the counter class might want something else to happen. Right? For example, they might want the counter to throw an exception, right, if it tries to exceed the maximum value. Someone else might want the counter to do nothing if you try to exceed the maximum value, right? So the count stays at integer max value, right? And then some other people might want it to wrap around to 0, right? So just to remind you what the counter class looks like, right? It's got a private field called value, right? It's got a constructor that sets the value to 0. It has some other constructors as well, but I'm not showing them to you here, right? It has a method that returns the value, right? And it has one method that lets you change the value. The only way you can change the value is to make it go up by 1, right? So advances the counter upwards by 1. And furthermore, its contract says is up here, right? So it says in the contract that the value wraps around to 0. Okay, so if I want to use this counter class for as the base class or as the superclass of a bunch of different counters, right? Then I have to do some surgery on the counter class, right? So I want to change the counter class so that I can extend it, right? And then change the way that advance behaves, right? So that's pretty easy to do, right? I inherit from counter, I override advance. Now the problem is if you're going to change the way that advance behaves, right? So in other words, if I'm going to change what advance does to the value of the counter, I have a problem. Because value is private, right? Subclasses cannot modify or do not have access to private fields from the superclass. Right? So if I subclass counter, I cannot access that field directly. Right? I can get the value of that field by calling the public method. Right? So I can call the value method to get the value of the counter. But I have no method here, right? No other method in the class that lets me set the value of the counter to some arbitrary value. Right? So I have no mechanism to set the value. Right? And so that becomes a problem now, right? Because if I'm going to change the way that advance behaves, I probably want to change what the value of the counter is. Right? And so this is a common problem that occurs when you try to extend a class that was never designed for inheritance. Right? So the counter class was, well, our initial counter class was never designed with inheritance in mind. Right? And this is one of the problems that you run into. Right? So if you don't have access to the source code of counter, you're kind of stuck. Right? Now you don't have any good way to extend the counter class. We do have access to the counter code, so let's change the counter code so that we can use inheritance. Right? So step number 1, I need to make the field value visible to its subclasses, but I don't want to make it visible to everybody. Right? So I don't want to make the value field public, because then anybody can go in and change the field to whatever value they want. Right? And now the counter class can no longer enforce its class invariance. right? It can no longer ensure that the value of the counter is always between 0 and integer max value. So if you are designing a superclass that's meant to be used for inheritance, you can mark the fields as being protected. Protected allows subclasses to access those members directly by name. Right? So in other words, if I change the value field so that its visibility is protected, any subclass of counter can now go in and change the value, change that field directly by name. Right? So in other words, a subclass can write this dot value equals something, and the value will change. Right? So that's good. Step number 2, I've got another problem here. That's fine. Why is that here? Oh, there's another constructor. All right, so here's the second constructor that we've got. Right, so this is the constructor that lets you set the value of the counter to some specified value. Right, so keep that in mind. I've got another problem. I've got this advance method that I want to change the behavior of. Right, but advance says, right, so this is a contract for advance. Right, now remember, in inheritance, right, the subclasses have to also obey this contract. Right? So the contract says if it hits integer max value, then it wraps around to 0. Right? If I don't change this contract, then the subclasses also have to implement advance so it wraps around to 0, which defeats the purpose, right? Because I want advance to behave differently. So now I have to change the contract as well. Right? So in other words, I have to put in some language that indicates that subclasses might change this behavior. Right? And that's easy to do. You just put in, but subclasses can override this behavior. Right? So anybody who uses the plain old counter, they get the behavior where it wraps around to 0. Right? But they need to keep in mind that subclasses might do something different. Right? So if they're writing code according to the contract of advance, right, they can't rely on the counter going back to 0 when it wraps around, when it hits the maximum value. Right? So whatever the code they write, they have to keep in mind that subclasses might change this behavior. Right? And that's fine. Right? So this is okay for everybody involved. Right? Why do I have to modify the contract for advance? Because subclasses are supposed to be substitutable for their superclasses. Right? If I don't modify the contract, then there's no way for subclasses to change the behavior of advance and still be substitutable. Right? All right, so now we can change the counter class so that it implements a different strategy when the counter hits integer max value. Right? So for example, I can create a counter that stops counting when it hits integer max value. Right? So how does this work? Well, I make a new class. Right? So I've got the class stopping counter. It extends the counter class. Right? No fields. Right? I don't need to keep track of the value of a stopping counter. Right? Why? Because it inherits the value field from counter. Right? So in other words, it already has a value. It just so happens that the value, the field, lives in the superclass. This is the other difficult thing about implementing inheritance. Right? You have to remember that some of your fields, some, many, all of your fields might not be in the class that you're writing. Right? In other words, they could be in one of the ancestor classes. Right? So here the value is in the counter class. Right? So there's no fields here. Of course, if you want to, right, if you need to for some reason, you are allowed to add your own fields. Right? It just so happens to be the case that stopping counter doesn't need to. Right? Now remember, inheritance is one way. Right? So if a subclass adds fields to the subclass, the superclass has no idea that those fields exist. Right? It's strictly one way. So what goes into the constructor body? Right? So my stopping counter, right, needs to initialize the value of the counter to 0. Right? Now that the value is protected, I can write this dot value equals 0 here if I want to, and that's fine. Right? But there's a better way to do this. Right? So remember what the purpose of a constructor is. It's to initialize the value of all the fields of the object. Right? Now how does a constructor in the subclass set a field that lives in the superclass? Right? If the field is visible to the subclass, then the subclass can set it directly. In inheritance, though, it's often the case that the superclass has private fields that you don't know about. So how do you set the private fields of the superclass? right? Well, you call the superclass constructor, right? Now, how do you call a superclass constructor from the subclass? You use the keyword super. So on the first line of your constructor, in a subclass, right, you should almost always call the superclass constructor, right? So the no argument stopping counter constructor calls the no argument counter class constructor, right? The keyword super means that you're calling the superclass constructor. You're making a constructor call, so you need the round brackets, right? If the constructor that you're calling has parameters, you just stick them inside the round brackets, right? And so that's how you call the superclass constructor from a subclass constructor. All right, so I'm going to stop there because I'm going to give you a bunch of rules regarding constructors and subclasses. There's actually a lot you need to know here, and hopefully what I tell you clarifies a bunch of things that I told you early in the course. All right, does anybody have any questions about today's lecture? All right, there is assignment 5 appeared last night. So your next assignment is out. Your next lab will also come out today or tomorrow, I think. It's a cute lab. Someone sent me a question. So I guess someone in the class got an internship interview with Amazon. And they sent me one of the Amazon test questions that they got and asked for help on it. So I'm going to use that in the lab. It's nice because it's an example of using interfaces to solve a problem. All right, so that's all I have for you today. I will see you tomorrow at 10:30, I guess.